Hello, I'm Peter and it's nice to see you again. I'm in the garden. It's in the middle of March and I'm in England, and you can see that we have a whole series of spring flowers out, and it's those that I'd like to talk about. We've got some hyacinths coming through, lots of daffodils around, a few of the snowdrops are still left behind, plus crocuses and a few tulips. And these are quite special. We're very lucky to have spring. Many parts of the world don't have a spring. We've lived in the Middle East and in Malaysia, and they really don't have a spring. It's lovely and warm most of the time, but it's noticeable that in Malaysia, for example, it's very lush, it's very green, but it's not very particularly colourful. And I think that's probably because plants don't have to struggle too much. They don't have to get on and try and reproduce and produce flowers at a particular time of the year. So you tend not to get them over there. And other places like Finland, where you've got snow for about 6 months of the year, I understand, you then don't get a spring. It goes straight from winter, the snow melts, and it goes straight into summer. The thing I particularly like at this time of year is that the flowers that we see around us highlight one of the things that I find particularly exciting in nature. And I'm going to take you through some of these and show you what I was told many, many years ago, and I've still found it a fascinating element of nature, that these plants and flowers really occur in threes. And I'll go into that in a bit more detail in just a moment. So we're inside now, and I've brought some flowers in from the garden. There's a crocus and a snowdrop here, and we've got some other spring flowers, daffodils that you'll recognise, some tulips and some hyacinths. And I just want to talk through these and just tell you why I find these particularly exciting. The flowering plants are all part of something called the group of the angiosperms, which are reckoned to have evolved about 200 million years ago. And sometime after that, they diverged into two groups, the Monocotyledons and the dicotyledons. Now, monocotyledon, as you'll understand, means one. And all of these flowers are from the Monocotyledons. And there's something I find particularly exciting about these. They've all got something particular in common. If we start by looking at the snowdrops, one thing that's very obvious, here's the leaf of a snowdrop. And you can see it's long and ribbon-like. And in fact, if we were looking at this, if we were able to look at it carefully, we would see that the veins all run in parallel along the leaf, going along the leaf here in this way. And the crocus is actually the same. You can see that it's got a main rib running down the centre, and the veins, again, if we looked at those, we would see that those are all running along in parallel along the leaf. The same is true if we look at any of these. If we look at the daffodils or the tulips, here's a tulip, you can see that's a bit more obvious. The veins are running down the leaf. So they've all got that in common. Now, the really exciting part from that is that it's the flowers themselves that I find so exciting. And this seems to be an unbroken rule in nature. It's very obvious in this snowdrop that the flower is arranged in a threes. You can see it's got three main petals here. The trumpet in the middle, there are three of those. And it's not quite so obvious, but if we look inside, and this is more obvious than the crocus, if we look at the crocus, you can see here that the petals are arranged in threes, two groups of threes. There's one group here and another group of three there. If we then look at the central part here, the stamens, the anthers, we can see that those are also organised in threes, as is the female part of the flower, which is the stigma down here. That also has three branches to it. Everything's in threes. I don't know why that is, but I find that very exciting. The same is true if we look at a daffodil. It's very obvious here. You've got 3 petals at the back here, and then 3 more here, so there's in threes. And if we look into the centre, again we can see that the anthers, the stamens, the male part of the flower is arranged in threes. There are typically 6 in here, and we can also see that in the stigma that is also arranged in threes. And this is true of all of these monocots. The monocots include things like maize and corn, the grasses. They're very well protected from being eaten by animals because they grow from the ground upwards. They come from a central rootstock. The roots themselves spread out. There's no main taproot. It goes out into the surface soil rather than going right down as a main taproot. They're all built on the same sort of principle. If we look at another example of one of our spring flowers, we've gone from snowdrops to crocuses to daffodils. We're now heading into the tulip time of year. And you can see here again that there's 3 petals, 2 lots of 3 in the tulip, and the central part where the stamens and the anthers are, the stigma, again are in threes. Seems to be an unbroken rule in nature that these are arranged in threes. If we look again at hyacinths, those are also arranged in threes. Exactly the same thing. The leaves are, you can see it very easily on here, the leaves are ribbed and the veins run parallel, and the flowers are also arranged in threes. Why are they arranged in threes? It's not obvious to me. I'm not quite sure, but what I do know is that anything else, all the other flowers that exist, aren't arranged in threes. I brought along some dicotyledonous plants just to give you an idea, to be able to compare them. So if I just bring these in for a minute. The first thing you can see is that the leaves are different. I know immediately that these are dicotyledons plants because they don't have the ribbon-like leaves with parallel veins running through them. This is a polyanther, and you can see immediately that the leaf is different. It's a dicotyledonous plant. It's what's called a compound leaf. And if I look at the flowers on this, they're definitely not arranged in threes. They're any other number, but they're not threes. This is actually arranged in fives. So we can see that that's different. If we look at this, a rose, the leaves quite clearly tell us that it is not a monocot, it's a dicot. And if we look at the number of petals, there's any number of petals there. There could be any number in there, but they're certainly not arranged in threes. And I've got a succulent plant here, which is just as a comparison, which has very thick leaves, but again, they're clearly compound. They're not narrow, thin, ribbon-like leaves. And the number of petals in there is a complete mixture, a whole load of different petals in there. The monocots clearly are distinctive with their threes. All the other plants don't have threes, and it seems to be an unbroken rule in nature. I think it's important to realise that these very special plants and flowers are worth preserving. I was quite shocked to find recently that the Spalding bulb fields in Lincolnshire have largely gone. When I was growing up, there were vast acres under cultivation growing bulbs of particularly tulips and irises, and these have largely gone now, and I think that's popularity of these plants is maybe not what it was. There might be other reasons for it, but it's be a terrible shame if we lose these fantastic plants and flowers which have been growing in this world for about 120 million years. We've been here for less than a million probably, so the world definitely belongs to them, and it would be a shame if we don't do something to preserve them and keep them. Anyway, I hope you found that interesting. I find it fascinating that this law of three seems to be applicable and never broken in nature. I've no idea why, but I shall continue to enjoy it for as long as they continue to flower and while I'm still here to enjoy them. So thanks very much indeed for listening, and I look forward to seeing you soon. Thanks very much indeed. Bye bye.